Now let us see some of the integrals of basic trigonometric functions, right? So we know that integral of sine theta d theta is cos theta, okay? And cos will be sine, okay? And tan will be log of secant, and so on, right? And then we'll perform some integrals on uh, I mean, in the previous session, we have seen some of the definite integrals. So let us perform the integral, that is integral theta 0 to pi by 2. Okay, this is cos theta d theta. Now, cos integral of cos is sine, and the limit 0 to pi by 2. Let us substitute sine pi by 2 minus sine 0, which is equal to 1. Okay, let us see a few more problems on this. So let us solve this. Here we have integral tan theta for the limits 0 to pi by 3. So tan theta is a log ln, that is secant theta, okay? And this is for 0 to pi by 3. So now this is ln secant pi by 3 minus ln secant t 0, okay, which is this is ln 2 minus ln 1, okay, which is this is 0, this is ln 2, okay. Now let us see for theta plus cos theta. Okay, first we'll integrate this theta, okay. uh, since it is with respect to theta, so it is theta square by 2, okay, 0 to pi by 3, and this is plus sine theta, this is 0 to pi by 3, okay. Now this is pi square, so it is pi square by 9 by 2 minus 0, and this is sine pi by 3, which is root 3 by 2, okay, minus 0. So this is pi square by 18 plus root 3 by 2, okay. Now let us solve this problem. Now secant theta integral will be ln secant theta plus tan theta, okay. This is for minus pi by 6 to pi by 6, okay. Now this is ln secant pi by 6, okay. We'll substitute pi by 6 plus tan pi by 6, okay, minus ln secant of minus pi by 6 plus tan of minus pi by 6, okay. Now this is ln secant pi by 6 is 2 by root 3 plus 1 by root 3, okay. This is ln 2 by root 3 minus 1 by root 3, okay. So this will be since denominator is same, so we can write ln 2 plus 3, which is 3 by root 3, okay. minus ln. This is 2 minus 1, 1 by root 3. Okay, so this we can divide this. So this becomes uh, ln 3 by root 3 multiplied root 3 by 1. Okay, which is equal to ln 3. Now let us see integrals of exponentials and logarithms. So here we have suppose we'll see the basic of this. E to the power of ax dx will be e to the power of ax by a plus c. Okay, or ln x dx will be x ln x minus x plus c. Okay, so uh, now let us see for integral x is 0 to 1 sine h of x dx. So this is cos hx. Okay, 0 to 1. So cos h, this will be somewhere around 1.543. This is minus 1. Okay, nearly equal to 0.543. So this is the answer. Now let us perform the integral on 0 to infinity e to the power of minus x dx. This is your function now, e to the power of minus x. So we know that e to the power of minus integral of this would be e to the power of minus x by minus 1 0 to infinity, and this can be written as minus 1 by e to the power of x 0 to infinity, and uh, this e to the power of infinity uh, which on a large becomes the value which is an that allows to grow, okay, to infinity, and it approaches to 0. So as in it grows and it becomes 0. So that would be this is 0. Uh, this is minus of minus 1 by e to the power of 0, which is 1. So which is equal to 1. Now this is integral 1 to e ln x dx. So we already seen that ln x dx will be x ln x minus x. Okay, and so 1 to e. So this will be e ln e minus e minus 1 ln 1 minus 1. Okay, so which is this is e. Okay, e multiplied 1 is e, and this is minus e, and this will be 0 minus 1. So here overall this will be 1. And now let us have a look at for integral x 3 to 4 2 to the power of x dx. Now this is 2 to the power of x by ln of 2, uh, which is 2 to the power of 4 by this is ln minus 2 to the power of 3 by ln 2. So this will be 8 by ln 2. Okay, after using the calculator, this is nearly equal to 11.542. Okay, now let us have a look at another topic. Okay, So now we'll see integration by polynomial substitution. The common method of performing integration is to make a change of variables. If any integral is one or variable, suppose x, it can be transformed to t or so and so. So and let us perform uh, the following integral here. Suppose if I have integral 3x plus 4 to the raise 5 dx. So it would be a very difficult or tedious to multiply since it is multiplied times, right? So let us substitute this as t 3x plus 4. So when you're changing this variable, you are changing even integrating with respect to uh, x also. And it will be t. So that will be dt. This is 3 dx. Okay. Or dx is 1 by 3 dt. So this will be integral t to the power of 5. And this is 1 by 3 dt. Okay. Now integration of this is very simpler. This is t to the power of 6 by 6. Okay. This is 1 by 3 plus c. Or we can replace this back again. So this is 3 plus 3x plus 4 divided by 6 divided by 80 plus c. Okay. So let us perform this integral. Okay. Now again, this seems to be very difficult to solve. So we can here look at this. We can replace this always. X cube plus 8 as t. So this will be 3x square dx is equal to dt. So we can replace x square dx uh, as dt by 3, right? So this is integral. And also you're changing the variables also here. That is when x is see when x is 1, t will be 9. When x is 2, t will be 16. So even this also this all should change along with that x to t. So this is 9 to 16. Okay. And this is root u by 3 dt. Okay. U power half, right? So it is 3 by 2. Okay. That is u to the power of 3 by 2. And this will be 2 by 3. Okay. And this is 9 to 16. Okay. So this is 2 by 9. Now this will be 16 to the raise 3 by 2 minus 9 to the raise 3 by 2. Okay. Now this, when you simplify it as 2 by 9 and 64 minus 27, or this is 74 by 9, or which is equal to 8.22 and so on. So this will be the answer.